Substituting the value, you have 20 is equals to 40 plus in bracket minus 40 minus 20 is equals to minus 40. You now have t is equals to 20 over 4 equals to 5 seconds. I. Time taken to cover PR. Taking the first equation of motion, you have that v squared, which is the final velocity, equals to initial velocity u plus acceleration times a times t. Substituting the value, putting the value, but we know that v is equals to 0 meters per second since it is at the final velocity, and u is equals to 40 meters per second. Substituting, we have that 0 is equals to 40 plus in bracket minus 40 is equals to minus 40. T is now equals to 40 over 4, which will now give us 10 seconds. Example 8. A ball has a mass of 0.2 kg and fell a distance of 30 meters. If air friction is negligible, calculate its velocity. Solution. Since the ball was dropped from a height and air friction is negligible, then kinetic energy gain equals the potential energy loss. Kinetic energy gained is in bracket half mv squared, which is equal to minus loss in potential energy, which is mgh. Half mv squared is equals to mgh, but mgh is equals to 0.2 times 10 times 30, which is 20 joules. Half mv squared is equals to half times 0.2 times v squared, which is equals to 60 joules. Making the final velocity the subject of the formula, we have v squared is equals to 60 all over half times 0.2, which will give us 600. V squared, letting the square root crossing the equality sign, we have the square root of 600, which will now give us 24.5 meters per second. Example 9. A body at rest is given an initial uniform acceleration of 0.8 meters per second for 30 seconds, with the acceleration is reduced to 5.0 meters per second squared for the next 20 seconds. The body maintains the speed attained for 60 seconds, after which it is brought to rest in 20 seconds. Draw the velocity time graph of the motion using the information given above. B. Using the graph, calculate I, the maximum speed attained during the motion, II, average retardation as the body is being brought to rest, III, the total distance traveled during the first 50 seconds, IV, average speed during the same interval as in II. Solution. A graph. After 30 seconds, the velocity v1 gained. The final velocity using the first equation of motion, we have v1 equals to u initial velocity plus at, which is equals to, by substituting the values, we have 0 plus 8 times 30, which is 240 meters per second. This enables the point A to be plotted so that OA is part of the graph showing the uniform acceleration. Also, change in velocity after next 20 seconds. V2 is equal to u plus 80. V2 is now equal to 240 plus 100, which will give us 340 meters per second. Thus, drawing the line AB so that AB or EF represents 20 seconds. Now, draw the line BC parallel to the time axis so that BC or FG represents 60 seconds. Finally, join C to D, which is 20 seconds further than G on the time axis. Plotting the velocity time graph. The vertical axis represents the velocity while the horizontal axis represents the time. From point O to A represents acceleration when at a time of 30 degrees. Then from point A to B, the body increases its speed from 240 to 340 at a time of 50 seconds. Then at a constant velocity, the body moves from B to C. Then at a time of 110, then it started retarding from C to D at a time of 130 degrees. V1 maximum speed attained during the motion. V1 over 30 is equals to 8. Then making V1 the subject of the formula, you have that 30 times 8, which will give us 240 meters per second. Also, change in velocity after 5 seconds is equals to V2 minus V1 all over 20, which is equals to 5. V1 maximum speed attained during the motion. V1 over 30 is equals to 8. Making V1 the subject of the formula, you have 30 times 8, which will give us 240 meters per second. Also, change in velocity after 5 seconds is equals to, in bracket, V2 minus V1 all over 20, which is equals to 5. V2 is equals to V1 plus 100, making V2 the subject of the formula and substituting the value of V1, we have V2 equals to 240 plus 100. V2, which is maximum velocity, is 340 meters per second. BII, average retardation along CD, is equals to slope of IV. Acceleration A is equals to velocity change over time. CG over GD is equals to 340 meters per second over 20, which will give us 70 meters per second squared. BII, total distance for the first 50 seconds, is equals to area of triangle OAE plus area of trapezium EABF, which is equal to half OE times AE plus half in bracket AE plus BF times EF. Substituting the values, we have half in bracket 30 times 240 plus half in bracket 240 plus 340 times 20. Now we have all in bracket 3,600 plus 5,800 meters, which will now give us 9,400 meters. BIV, average speed for 50 seconds. Distance over time is equals to 9,400 meters over 50 seconds, which will now give us 188 meters per second. Example 10. A stone dropped down a well, takes 2 seconds to reach the water surface. Calculate A, the velocity with which the stone hits the water. B, the distance of the water surface from the top of the well shaft. Solution. Using the first equation of motion, V equals to U plus AT, where V is equals to final velocity, U is equals to initial velocity, A is equals to acceleration due to gravity,